If you're at all familiar with 3D printing, there's a pretty good chance you're also familiar with PLA. PLA is easily the most commonly used filament for FDM 3D printing, but not all PLA is created equal. Here in front of me, I've got 3 different types of PLA, all from the same brand, eSun. I've got standard PLA, PLA+, and then ePLA-ST, or Super Tough. So I've created a barrage of tests to put each of these through to see how each one fares against the other. So we're going to take a look at all 4 of those tests now. For our first test, I've rigged up this kind of ugly little setup here to be able to test the tensile strength of these filaments. We've got our hooks, I've got a bucket, and I've got a crane scale. This will help us to determine how much weight each of these can handle before they snap or bend or break. Alright, first up we have our standard PLA hook, the blue regular PLA. I've got my scale set to 0 with a bucket with nothing in it. So let's start adding some weight. We're going to start with these macho 2-pound weights here. Okay. $22.5 pounds. Okay, still holding 30 pounds. Oh, I see some stress fracture right here. I don't know if it's gonna make it. Okay, it looks like it's stretching to me. Got a definite crack right here at 40 pounds. Okay, oh, it's really stretching out here. I can barely handle it. I'm afraid this thing might break. We're at about 51 there, which is ironic because that's only 50 pounds of weights according to the dumbbells. Let's go 5. Still hanging in there. Let's do another 5. And there it goes. So now we're going to move on to PLA Plus in the red here. Let's do the same thing. We'll see how it goes. Again, I'm going to start this around 50 pounds and we'll go up from there and see how it handles it. So we'll put a 20 in there. Okay, here's 10 more. Including at that bottom joint and some definite motion right in here. Okay, we're at 51 pounds. Okay, I'm going to go with some 5s now. Let's do 5 more, so we're at 56, according to the scale. Okay. Yeesh! Okay. So that was 56, I was putting in 5 more, so we got somewhere between 56 and 61. Alright, next we've got the ePLA-ST. Let's see if this one does any differently. Again, we're going to start out with 50 pounds. 20. 40, definitely seeing some stress fracturing again along that arm. It's really already looking very stretchy. Wow, it's stretching big time. I don't know if it's going to even take this 50. I feel like it might slide off. It's stretching way more than any of the others. I haven't let go yet. There we go. Yeesh, 51. It's just barely hanging on. It's about to slip off. There we go. Oh, interesting. Look at this. Okay, so it actually, some of the filament strands, some of the individual layers actually separated themselves. But boy, that one stretched way more than the other ones did. Test number 2 is the smash test. I've got a 20-pound dumbbell that I'm going to be dropping from 20 inches onto the face of each of these hooks. We'll test each of the filaments and see how well they hold up after this big smash. Starting with PLA, we've got a nice smash with that dumbbell right onto it. And you can see in the corner here, it definitely took the majority of the beating. So it smushed down and it looks like it actually blew out a little bit. I took a really good hit here. The dumbbell landed on it twice, tipped over, and then you can see a little strand hanging out the side there because it actually broke it apart. Upon closer inspection, we see the infill is visible. It did smash that apart and did a pretty good number on this piece. Now moving on to PLA Plus. We got a really big impact on this one and it blew it apart right away. We got a good solid hit on here, and that corner of the carabiner piece here just really got smashed to pieces. In fact, if you look at it closely, you can see it broke right out there, and then as we flip it up onto its side, you can actually see where it just blew that whole part almost right off the side. Now the PLA-ST lived up to its name of being super tough here, it did kind of bounce out of the way, and it's a more flexible material, and you can see that it actually smushed down rather than breaking. And that's what we've seen pretty consistently with this material. It can handle a little bit more, especially as far as impact is concerned. Test number 3 is the twist test. Let's see how well they can handle being twisted against themselves and see which one holds up best. Just like before, we're going to start out with the blue PLA and see how much this thing can take before it snaps. So in each of these cases, I've got them held down into a bench vise, and I'm using an adjustable wrench here to just twist and twist until it can't take it anymore. And it looks like we're starting to see some tension there, and it snaps. There it goes. You can see in the playback, this is a pretty clean break. Broke right off, a little bit of debris, and we scored 43 degrees of twistability on this one. Moving on to the PLA+. Same scenario setup here. We're going to pull this as far as we can and see how far this thing can twist. We're looking for those little signs of tension. We're starting. Oh, there it goes. Okay. So with this one, it broke but didn't break clean off. And we have a much lower degree of twistability here with only 33 degrees. Finally, the PLA-ST or Super Tough. We know this is going to be a little bit more flexible, but let's just see how much more flexible this stuff is. Okay, as it's moving probably beyond what the other two already did, and it's still going. Okay, still going. There we go. And this one does not break. It just kind of slowly marshmallow separates here. It almost looks like a soft material. And look at this, 64 degrees of twistability. So there are our final results, 43 degrees, 33 degrees, and at almost double that, 64 degrees for the PLA Super Tough. Now test number 4 is a real-world application of these different filaments. So I actually use a lapel mic for all of my videos. I actually have 3 different YouTube channels, and I wear this all the time. Now what I ran into was that I couldn't find something that would actually point the microphone up. I usually just wear a t-shirt, so I found this great design, and I'll put a link to the STL in the description below. The guy who actually made this has been a lifesaver for me because I use this thing constantly. Now I wear a lot of red shirts, so I'm wearing a red one right now, and this one is actually made out of the PLA+. Now one cool thing is I've been using this one for months, and it has not broken, it has not damaged, it hasn't stress fractured, anything like that. It's been great. I can't say the same about regular PLA. In fact, this is my my 5th microphone clip because the first 4 all broke because I did them out of standard PLA. So I've got this one here, standard PLA, broken. Another one, standard PLA, snapped right in the middle. I've got the standard PLA from eSun here, and the arm broke right off, as you can see there. So none of those have worked. I haven't actually even tried this with ePLA Super Tough because I haven't needed it. PLA Plus has been sufficient, and I've been using this for way longer than any of the PLA ones with 0 issues. So at some point, if this does break, I will try this out with the Super Tough and see if that makes any difference. But like I say, haven't needed it. So there's a great real-world application for one versus the other. Now these were all provided by eSun, so I will put links in the description below so you can check these out. Now if there's any other types of filaments you'd like me to compare, I'd love to do that. I've kind of got a fun little setup where I can do that now. And so if you want to compare maybe the ST to PETG or something like that, leave a comment below and I'll definitely take a look at that. Now in the meantime, if you want to learn some of my favorite 3D printing accessories, I've got a video right here that you can check out, my 7 favorites. I'm Nils with the 3D Printing Zone. Thanks for watching, and we'll see you on the next one.